If you want to have the copy of the module, I've linked it in the description of this video. Describing sets. There are three ways to do this. You have the roster method, you have set builder, and then the verbal one, basically describing the set. Let's look at the roster method first. The set can be defined by listing all its elements separated by commas and enclosed within braces. This is called the roster method. So we have an example here, set B, which is 2, 4, 6, 8, 10. And we have set X here with A, B, C, D, and E. I'm going to add this with Z. And what you can do, if it's an infinite set, you can add some ellipses, meaning it's a continuation. So let's say it's going to be negative 1, 0, 1. Then I'm going to say going to continue also on the other side. Ellipses, you can put that in roster method. Next, we have the set builder notation. It's my favorite. The set can be defined where possible by describing the elements. This is called the set builder notation. For example, we have set C here, and this is read as C is the set of elements X such that X is an integer greater than negative 3. So C is the set of element X, this is right over here, such that X is an integer where X is greater than negative 3. Another example would be D is the set of element X such that X is a river in a state. The set builder is simply a set, let's say set A here, and we're going to put all of its elements in a certain variable, let's say X, such that, and we can describe that X is an even number. We can even add more by adding a comma where our X is less than 10 but greater than 1. Basically, it's between 1 and 10. We have then the final way, which is verbal description, in which the set can be defined by defining its elements. Here are some examples. The set of presidents of the US who were still alive June 15, 2009. The set of all great mathematicians in the past, the set of all positive numbers less than 10, the set of all letters in the modern English alphabet, which is this picture right over here. The verbal description is more like the set builder, but in a more informal way. Now we know the three methods. Let's do some activity. Number 1. Which of the following is the set of odd whole numbers less than 10? We have three selections here, A, B, C, and let's check whether one of these is the set that describes number 1. The set odd whole numbers, so we start from 1 and it's just odd numbers, so that is your 1, 3, 5, 7, 9. That is less than 10. That is less than 10. Looking here at C, set E is 1, 3, 5, 7, 9, which is the perfect depiction of number 1. Number 2. Which of the following is the set of all oceans on Earth? We have here three choices, and let's look at its elements. Looking at A, we have set E, Amazon, Nile, Mississippi, Rio Grande, Niagara. B, set F, Asia, Africa, North America, South America, Antarctica, Europe, Australia. C, set G is Atlantic, Pacific, Arctic, Indian, and Antarctic. A is just rivers. What we're trying to find are oceans. B are all the continents. I believe then C is our answer. Number 3. Translate the following set builder notation to roster method. From defining each element, to listing out each element. So we have A here. H is X such that X is an even number between 19 and 31. Easy enough. Let's just put our set H here and list out all even number between 19 and 31. So we're going to start after 19. The even number after 19 is 20. And let's continue on until before 30. And 30. I believe these are all even numbers that are between 19 and 31. B. Set I is X such that X is an odd number between 19 and 31. Easy enough. Let's start with our set I here and let's list all the odd numbers between 19 and 31. But you have to take note that it is between 19, so you're not going to start at 19. You're going to start the odd number after 19. Same thing with 31. You're going to end at the odd number before 31. And let me just list it all, starting with 21 and 29. Let's close it. We have now C. Set J is X such that X is a whole number between 3 and 4. If you think about it, is there really a whole number, not a fraction, not a decimal, but a whole number between 3 and 4? Nada. So, J is actually a empty set. Or you can just denote it as this symbol. Now we have the set K is X such that X is a number between 50 and 100 that is divisible by both 7 and 13. We're going to try to find a number between 50 and 100 that is also divisible by 7 and 13. And one easy way to get this is just by multiplying 7 and 13, which will give us just one number, 91. Lastly, we'll have E. Set L is X such that X is a number between 50 and 100 that is divisible by 7 or 13. This is different from D, where it is divisible by 7 and 13. We are going to find multiples of 7 between 50 and 100 and multiples of 13 between 50 and 100. Let me just list it out. Okay, these are multiples of 7 between 50 and 100. These are multiples of 13 between 50 and 100. Let's just list it off. When we arrive at 91, it's not going to be 91 and another 91. No, it has to be unique. So I'll just grab 191. And finally, we have 98. And these are numbers between 50 and 100 that is divisible by 7 or 13. Number 4. Translate the following verbal description to roster method. Each of these are verbal description, and we are to list them out. A. Counting numbers that are multiples of 4 that are less than 21. A is just counting numbers then that are multiples of 4 and less than 21. I'm just going to designate M as our set. And remember, counting numbers are also your whole numbers, which are multiples of 4 less than 21. Let's list them out, starting with 4 and 20. That answers that. Then we have B, the counting numbers that are divisible by 4 that are less than 20. Almost the same thing, but it is less than 20. I'm going to designate N as our set, and as list it as the same above. And 16 because it should be less than 20. C, even numbers that are multiples of 3 between 30 and 50. We have even numbers that are multiples of 3 between 30 and 50. This is the same as saying get numbers between 30 and 50 that are divisible by 3 and 2. Or you can even say multiples of 6 between 30 and 50. Going to designate O as our set, and let's start with 36 and 48. That should be all even numbers that are multiples of 3 between 30 and 50. Then we have D, odd numbers that are multiples of 3 between 30 and 50. So we're dealing with odd numbers this time. That is multiples of 3 between 30 and 50. I'm going to designate P as our set, and let's list them out starting with 33. 36 is an even number, so 39. 42 is an even number. Next up, we have 45. And lastly, we have 45 because the next odd number that is multiples of 3 is more than 50, which is 52. Finally, E, the last for this video, odd numbers that are multiples of 2 between 0 and 100. If you think about it a little bit, odd numbers that are multiples of 2, which basically means this is even, is there a number that is both odd and even? There is none. Let's designate Q as our set and open and then close. Those are the different ways to describe set, roster method, set builder, and verbal definition with activities. That's it. End.